Hello chaps, right, this is our first online lesson. Good luck to all of us. Very easy, a very quick recap of something we learned last year. It's not difficult, but I know it's a little bit confusing, okay? And I gotta say, it's not a huge part of math, so don't worry if you're getting a little bit too confused with it, okay? Right, so numbers, we're looking at numbers. It turns out numbers come up in families, okay? And yeah, they come up in families. So we're going to look at all these different families that actually exist, right? The first family is what you call the natural numbers. We usually give them the letter N. And the natural numbers, I would call them hide and seek numbers. So you know when you play hide and seek, everyone hides and then one person counts, right? What does he count? He says 1, 2, 3. He just counts. These are the natural numbers. 1, 2, 3, and so on and so on. 4, 5, carry on. Okay? These are all the natural numbers. Whole numbers, okay? We usually give it the letter N, the same N, but with a 0. And the name suggests what they are. They're basically the same as the natural numbers, 1, 2, 3, 4, but also 0. So we just add the number 0. These are the whole numbers, okay? Now, Z stands for, is the letter that we use for integers, okay? Integers is kind of like the whole numbers, but you add also the negative numbers. Okay, so we can have 0, 1, 2, 3, and so on and so on, but also -1, -2, -3, and so on and so on and so on and so on. These are what we call the integers. Okay, until here it's pretty easy. Next thing, now it gets a little bit more confusing. Okay, now comes up the rational numbers. Okay, the rational numbers are basically all the integers, okay? So it's going to be -2, -1, 0, 1, 2, etc., etc. All the same as the integers, but now we're adding to it all what we normally call the fractions, okay? So 2 over 5 minus, let me just jump here, -3 over 7 or 72 divided by 5. If you can write down a fraction, an integer divided by an integer, if you have an integer divided by an integer, it could be positive, negative, then it's a rational number. Okay? There's one more little thing I need to talk about it, but we'll do it in a second. The next group are what we call the irrational numbers. Okay? The irrational numbers are those that are not rational. In other words, you cannot write them as an integer divided by an integer. Now you might think, hang on, can't any number be written as an integer divided by, can't any number be a fraction? Well, the answer is no. So for example, most famous example is square root of 2. Okay? Square root of 2 cannot be written as a fraction. Okay? Another one is square root of 5. Okay? These numbers cannot be written as a fraction. Can't write it as an integer divided by an integer. Another class of irrational numbers are the ones that have the letter pi. Okay, you remember pi 3.14 blah 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 blah, which is to do with the circumference of the circle. That's also an irrational number. Okay. Now I'm gonna pause here for a second. We'll just carry on. So this is one way of deciding whether a number is rational or irrational, okay? But sometimes it might not be shown as a fraction, okay? For example, you have 0,2, okay? Yeah, I'll write it down here, 0,2. 0,2, okay, is actually equal to 1 over 5, okay? It only has one decimal place. Some other numbers might be, let's say, 0,25. So it might have 2 decimal places. Okay? If it has a finite number of decimal places, that means it might have 1 decimal place, maybe 2, maybe 3, maybe 17, but it's going to end at some point, then we're going to say it is rational. Okay? Q. Okay? Q stands for rational. I didn't tell you. Okay? The letter for rational is Q. I don't know why we use Q. Okay? So that's one way of figuring out that the number is rational, if it has a finite number of decimal places. But sometimes, taking for example the number third, 1 over 3. you put in your calculator 1 over 3, what you'll get, I'm sure some of you will know, you'll get 0.3333, it carries on. In other words, 0.3 recurring. Okay, recurring. Okay? Now, in this case, there are infinite number of decimal places. It doesn't stop after 1, 2, or 3, or 17. It carries on forever. So does that mean it's irrational? No. It's still rational because it's recurring. It repeats itself. There's a certain pattern. Okay? So that's also still rational. Okay? Now, I'll give you another example. Okay? You might have a number 0,124, 124, 124, and it repeats itself. Okay? So you could have an infinite number of decimal places, but because it repeats itself, we say it is rational. Okay? So if that's rational, what about irrational? Okay? I'm going to write that down here. That's rational. Okay? What about irrational? Okay? The letter we use for irrational is the same Q with a little line. This little line in math tells you it's not. So Q line means not rational. So if you put in pi, or if you put square root in your calculator, go on, get your calculator. I'll wait here. I'm not going to go anywhere. Put in square root of 2. Okay? What you're going to get is 1, I think it's 1,4. Do you know what? I'm telling you not to do it. Let's do it. Okay? So square root of 2 SD. I'm getting 1,4142 13562. And now at this point it looks like it stopped, but it only stopped because the calculator can't calculate more accurately. In fact, it is going to carry on. Okay, if I use the more powerful calculator, it will can give me another 100 decimal places. But the thing is there a pattern here? Is there something that repeats itself, like here, like here? The answer is no. Okay, it doesn't repeat itself. So irrational. The irrational decimal, it doesn't repeat. There is no repeat. That's how you can test. Is it rational because it repeats itself? Irrational, it doesn't repeat. Okay, right. What are real numbers? Well, the rationals and the irrationals, if you put them together, these are all real numbers. Okay, so 0, 1, minus 2 over 5, pi, square root 2. All these numbers, they're all real. Okay, they exist. They're really real. Now, at this point, you're probably telling Mr. Lesher, what the hell are you talking about? I mean, okay, real number. That means there are some numbers that are not real. And the answer is yes, there are numbers that are not real. If you remember, we had that discussion last year. Okay, so let's have a look at square root of 4. Okay, how do we find the square root of 4? It's basically a number that if you square it, you'll get what's inside here. So the square root of 4 is 2. That's not a problem. Let's have a look at the square root of 1. Well, that's again not a problem. The answer is 1, right? Because 1 squared is equal 1. Okay? So now let's have a look at the square root of minus 1. Okay? Remember we spoke about it last year. Now the square root of minus 1 is either going to be, first place you might think, oh, it's minus 1. So what is the square root of minus 1? Maybe it's minus 1. But if the square root of minus 1 is minus 1, that means that minus 1 squared must be equal to 1. But that's nonsense. Minus 1 squared, minus 1 times minus 1 is 1. It's not minus 1. Sorry, it should be minus 1 because that's what we have here. But we know it's not. It is 1. So it can't be minus 1. So then you think maybe square root of minus 1 is actually 1. But that also doesn't make sense because if the square root of minus 1 is 1, 1 squared should be equal to minus 1. And that is obviously nonsense. 1 squared is 1. So the answer is that the square root of minus 1 is actually not a real number. But what does it mean not a real number? It just doesn't exist, is it? It does exist. There is a number like that, and we call it the letter I. We give it the letter I. Now, we're not going to use it in maths. If you learn AP maths, you will. But in maths, you don't need it, okay? All you got to know is that square root of minus 1 is not real. For the same reason, I think you will convince yourself that the square root of, let's say, -4 is also not real. Okay? These are not real. Okay? Let me just get myself some space here. I will need a little bit more. Okay? So, square root of -1, not real. Square root of -4, not real. What about the square root or the cubic root of -8? You might think, hang on, it looks like every time I have minus under the roots, then it's not real. But that's not true. We have an answer for the cubic root of -8. The answer is -2. Why is that? Because -2 cubed, -2 times -2 times -2 is -8. So the cubic root of -8 is real. Okay, it's -8. In fact, it's an integer. Okay, but the square root of -4, the square root of -1, every time basically you have a square root of a negative number, is not real. Another class, last class of not real numbers are things like 6 divided by 0. Okay, if you put 6 divided by 0 in your calculator, you'll get some kind of error message. Okay, in prep you were told that it's undefined. Okay, right? That also means it's not real. Okay? So we have two classes, two kind of not real numbers. Either square root of negative numbers, or if you divide by 0. In both cases, they're not real numbers. I'm going to pause here for a second. I'm going to go over a couple of kind of tricky ones. Okay, so before we end, this video is getting a little bit long. I want to just look at some examples, maybe a little bit tricky one. So they asked me, what did they ask me? I need to explain whether this number is rational or irrational. Okay, so the best way of doing it, I'll just put a cubic root. Hopefully you guys know how to do cubic roots. And I'll put 33. And I'll write equal, and what I'm getting is 3.20753433. I don't see any pattern. It carries on, there's no pattern. So that's going to be irrational. Okay? That's going to be irrational. Okay? Cubic root of 27 plus 1. So first of all, I've got to do, well, I'll just write it down. Cubic root, what is 27 plus 1? I don't need to write 27 plus 1. You can do that in your head, right? It's 28. So cubic root of 28, I'm getting 3.0365888972. Again, it carries on, and there's no pattern, so it's going to be also irrational. Now, this is the tricky one. Square root of 2 divided by square root of 2. Immediately, you might say, hang on, I remember Mr. Lesham telling me square root of 2 is irrational. But is it irrational? No. Because what is square root of 2 divided by square root of 2? I can cross cancel, isn't it? Okay, so it's 1 divided by 1. It's 1. And 1 is obviously a rational number. Okay, so don't get confused there. Right, guys, you can do now exercise 1. I'll see you in the next lesson.